Assalamu alaikum. Hello everyone. Today we will explain how to use two-dimensional interpolation using tensor product of Chebyshev system, or you can use a tensor product of polynomials. Let phi m and psi n the basis functions. These functions here are Chebyshev functions, but we can choose also polynomial functions. We can approximate our function as the following form. And we have to determine the constants here. A brief abbreviation of this formula, we can use the tensor product, which is we can use it in Matlab by cron command. So we can write u equal to psi y tensor products with phi x multiplied by c. C is a column vector which we have to determine. We will understand this formula by the following example. We want to interpolate using the tensor products of two Chebyshev systems on the interval from 0 to 1 these points. We have 3 by 3 grid, and we can write a vector, a matrix X, XYZ, XYZ positions of these 3 by 3 grid. So first, let us take this line of code and we put it in Matlab. We'll execute this. Okay. And if we use the Chebyshev functions, these two systems of Chebyshev, of course we can use polynomials here. Then we can write uxy by the tensor products of these two systems. And we have here a vector is a constant. We have to determine this constant. So if we write these codes, this is x, here our choosing system for interpolating in x direction, and this is y, the functions of interpolation in y direction, and we take cron products in Matlab to determine uxy. If we take this two lines of code, and execute it, it takes CLC, clear command windows, and Z has this form. The same form as here, uxy, and we have to determine these constants a in the following section. Now we have calculate symbolic expression for u all we have to do is substitute the values of x and y and calculate this function. So here we substitute the values of xy in z, and we get a matrix RR. Of course, we have 9 points, and by substituting, we have a matrix RR, and the left-hand side U is x3, the third coordinate of this system, and by RR backslash x3, we can get the constant C. We can calculate these constants by copy and here paste. So evaluate, and these are the constants of our function here. The same values are written here. So we calculate now the constant, and this is our interpolation function U. Now we will draw the surface which passes through these points. Capital Z here is the symbolic form of U. This is U. Capital Z is the symbolic form. And to calculate the interpolation points, we substitute the first coordinate and the second coordinate in this formula of Z, and we get Z1 here. We take, first of all, we take x1 from 0 to 1, step 0.05, and y1 the same vector. We take mesh grid of x1, y1, and then we calculate the function U. Here we note Z by substituting x1, y1 in this function, and we draw this function as a surface, and we plot the points of our interpolation. Here are the grid of our points on this surface to get this this figure window. Here are the interpolation surface, and the red dots are the interpolation points. This is how we can use two-dimensional interpolation. Thank you very much.